Alright, sorry I'm doing a second video because my other video kept having weird, like the screen kept going black, so I just decided to restart my computer. Alright, so I left off on example 2. We're going to draw a card from a standard deck of 52 playing cards, and we want to know the probability that it is a face card or a spade. So we're going to do the probability that it is a face card plus the probability that it is a spade, but we have to subtract off the probability that it is a face card and a spade. So the probability that it is a face card is going to be 12 out of 52. The probability that it is a spade is 13 out of 52. There are some spades that are also face cards. Spades are that one. And we have the jack, the queen, and the king that are face cards and spades. So that's going to be subtracting off 3 out of 52. So we add and subtract the numerators. We get 22 out of 52. That reduces to 11 out of 26 for our fraction. Turn that into a decimal. Get approximately 0.423. If we need to know the percent, that would be 42.3%. In this example, we've got 200 students in a senior class, 200 seniors. 113 students are either varsity athletes or are on the honor roll. Remember, the word or means that they could be both, or they might be one or the other. There are 74 seniors who are varsity athletes, and there are 51 seniors who are on the honor roll. What is the probability that a randomly selected senior is both a varsity athlete and on the honor roll? So the 113 out of 200, that's the or. That would be the, oops, sorry, I'm off the screen. That's the or. That would be the probability of A or B. Okay, we need to find the probability of A and B. But I can find that using this probability of A or B formula. So the probability of A or B is the probability of A plus the probability of, plus the probability of B, subtract off the probability of A and B. Now we want to solve to find this portion right here. We already know the probability of A or B is 113 over 200. The probability of A would be seniors who are athletes. That would be 74 out of 200, plus the probability of seniors that are on the honor roll would be 51 over 200. Subtract off the probability of A and B, and I'm just going to call that X because I don't want to keep writing all of that every single time. So we need to solve for this missing piece right here. See, to get this by itself, because it's negative, I am going to add the X to both sides. And at the same time, I'm also going to subtract 113 over 200. So I will get X over here, which is probability of A and B, equals 74 over 200 plus 51 over 200, and then subtract 113 over 200. So we'll go ahead and simplify that. We'll get 12 over 200, which is 6 out of 100. Oops. When we talk about 6/100ths, we get the decimal of 0.06, and we get the percent of 6%. our last example 4 is we're going to solve a real life problem. And this is actually one place that a lot of probability is used in real life. Here we have the American Diabetes Association estimates that 8.3% of people in the United States have diabetes. Suppose that a medical lab has developed a simple diagnostic test for diabetes that is 98% accurate for people who have the disease, but only 95% accurate for people who do not have the disease. The medical lab gives the test to a randomly selected person. What is the probability that the diagnosis is correct? So I have a tree diagram, that's what it's called. I have a tree diagram here, and this talks about the entire population of the United States. So this would be everybody in the United States. Now it's going to branch off. It's going to branch off into a population, a part of the population of the United States of the people that do have diabetes. And up here it says it's estimated that it's 8.3% of the population do have diabetes. So if we go off to this side, we're taking 8.3% of the United States. And I'm going to turn that into a decimal, 0.083. So that's 8.3%, but I put it in a decimal. That's the percent of people that are going to be on this side of the tree diagram. So if 8.3% of people go to this side, that leaves everybody else going to the people who do not have diabetes. And remember, this A with the line over it also could look like A with an apostrophe, means the complement. Means the complement of event A. So here's event A. The complement event A would be everybody else. So I take away 8.3% from 100% and I get 91.7%. Turn that into a decimal, and I get 0.917. So that makes up the entire United States population. Now we're going to look at just people who do have diabetes. This test says if the person does have diabetes, 98% of the time the test will work. It will be accurate. So if a person has diabetes, the correct diagnosis from this test will be 98% of the time, so 0.98. That means 2% are diagnosed incorrectly. And then we're going to look at this separate complement of the person that does have diabetes. If a person does not have diabetes and they are tested, it says up here that 95% accuracy is what we'll get for this test. So 95%, it will be the correct diagnosis, which means 5% will be incorrect diagnosis. So that's for the separate portions of people who do have it and people who don't have it. So now this is asking, what's the probability that the diagnosis is correct? So we have two completely separate probabilities to deal with here, but we have to combine them. So I'm going to do this in words first. I feel like I need to zoom out just a little bit. Okay, I'm going to do this in words first. So I'm going to talk about doing the probability that the diagnosis is correct. That's what we're trying to find. Probability that the diagnosis is correct. So what we need to have correct diagnosis would be the probability that the person has diabetes and diagnosed is correct, plus the probability that person does not have diabetes and the diagnosis is correct. Now let's talk about that in symbols. So we're going to have the probability of event A, and we're going to multiply that by the probability of event B given event A. So looking up here we need to find the probability that the person has diabetes, event A, given that they had the correct diagnosis. So we're saying, what's the probability that this actually happens to the people that have diabetes, that there is a correct diagnosis for the people that have diabetes? That's what this formula right here is going to give us. So we're kind of combining that with addition, which is, we were doing the multiplication of probabilities before, the conditional probability. And now we're going to do another conditional probability right here. We're going to do the probability, and we're going to say the complement of A. And we're going to multiply that by the probability that we have a correct diagnosis, given that we knew that the person does not have diabetes. So we're saying, here's a condition for this one. So the probability of A, of event A from up here, probability of event A is 0.083. And we're going to multiply that by 98% accuracy. And then we're going to do the probability of the complement of A, which is 0.917. We're going to multiply that by the 95% accuracy. I don't know. If I were thinking about this just without knowing much about probability, I would think it would be maybe somewhere right in between 98 and 95. But when you actually multiply this out, we get, multiply this out and add these together, we get approximately 0.952, which is, as a decimal, 95.2% accuracy for the test in general. So what I was trying to say is, I would think if one's 98 and one's 95, that you'd think that it would be somewhere in between 98 and 95, which it is, but it's really close to only 95% accuracy, because the 98% works on such a small amount of the entire population, where it's 95% on the majority of the population. So you kind of have to think of this as being more like a weighted average, where this weighs way heavily compared to this right here. So 95.2% accuracy. Your assignment for tonight will be on big ideas. And make sure you contact me if you need any help. Have a great day.